With this example, consider a random variable x that possesses an exponential distribution with mean 4 and use the method of distribution functions to derive the density function for u equals 3x plus 1. Second part, use the method of transformations to derive the density function for u. Okay, let me write down the information we have. We know x has the exponential distribution. Therefore, we can write down fxx equal 1 over 4 e negative x over 4 x greater than or equal 0. Now I will write down CDF of u. This equal probability u less than or equal u. Now we can substitute 3x plus 1 instead of u. We have here x less than or equal u minus 1 over 3. Okay, so what is this? Let me remind you, think about fyy. This is, I say fya. Okay, so this equal probability y less than or equal a. It means here y, and here a, here a. Same thing over here. So we have here x, therefore we can write down fx, but instead of a here we have u minus 1 over 3. Now we find the f, simple fuu, pdf of u. This equal derivative of capital Fu, cdf. So according to this relationship, derivative of this, what is the derivative of this? 1/3 f prime x u minus 1 over 3. So f, capital F prime, we can write down 1/3 simple fx u minus 1/3. We know simple fx here 1/4 e power negative x over 4. So now I can use that 1 over 4 e negative x. Instead of x here we have u minus 1 over 3. Therefore u minus 1 over 3 divided by 4. So then we can simplify 1 over 12 e to the power negative u minus 1 divided by 12. What is the range of u now? So we know here you see x greater than equals 0. So I use that. Then u minus 1 over 3 greater than equals 0. From this you will get u greater than equal 1. Therefore u greater than equal 1. Now I can write down fuu equal 1 over 12 e negative u minus 1 over 12 when u greater than equal 1, otherwise it is 0. The second part is use the method of transformation to derive the density function for u. What is the first step of this? Find the inverse function of x. U equal 3x plus 1. So inverse function is u minus 1 over 3. Then evaluate the derivative. But this is the h inverse u. So derivative of h inverse u, this equal 1/3. Okay, now we can consider the this equation fuu equal f x h inverse u d h inverse over du. Now we need to find the f x h inverse u. So again we know fxx, it is exponential distribution. So 1 over 4 e negative x over 4 when x greater than equal 0. Therefore we can use fx h inverse u. H inverse u is u minus 1 over 3 1 over 4 e minus u minus 1 over 3, then 3 times 4 4 is 12. This one. FUU can be written 1/4 E negative U minus 1 over 12. The H inverse over du 1 over 3. So this equal 1/12 E U minus 1 over 12. Now we need to find the range. What is the range? Here we know x greater than or equal 0. Therefore, u minus 1 over 3 greater than or equal 0. Then u greater than or equal 1. Therefore, we can write FUU, PDF of u equal 1/12 E negative u minus 1 over 12 when u greater than or equal 1. Otherwise, it is 0. We get the same answer from the both methods.